All right, so today is going to be it's all yours. Okay, today is all yours today, an all-day homework session. Yay. Today is Thursday, September 17th. Whoops, no, it's not. Oh my, as usual, out of it I am. Okay, today's Thursday, October 8th. Today's Thursday, October 8th. This weekend, I can finally start grading like this thing, for example, right? Okay, because withdrawal deadline's coming up in 2 weeks. I better really start grading things. Now remember, today, only chapters 2 and 3 are due. Okay, it's due tomorrow, Friday. Tomorrow is due tomorrow, Friday, October 9th at midnight, end of day. Okay, for chapters 2 and 3. No trig is due tomorrow. Don't give me any trig tomorrow. Now, I hope that you're catching up, right? I hope that you're caught up. I hope that you're working on the trig, but don't turn any trig tomorrow. Hopefully, though, maybe you'll start working on the trig tomorrow, actually, right? But try to get caught up on the trig. All right. Okay, but the idea is that I was going to have the introductory trig before today, so that it shouldn't be too pressing. Although I know it takes time to review these things for some students. And then we'll continue with trig next week. Withdrawal deadline is in a couple of weeks, right? Friday, October 23rd. So obviously I got to get something returned by then, right? Okay, now any general questions before we proceed? We are recording, yes? All right, and I'll post this on, I almost said Facebook. No, not Facebook, YouTube. I'll post it on YouTube. Although, if for some reason you want me to pause the recording for privacy, let me know, maybe privately in chat, and that's fine. But I think students really appreciate having these recordings, like these 3-hour recordings online. All right, happy Thursday. Okay, any questions before we proceed? Any questions before we proceed? All right, so. Okay, so I'm going to go through, and of course you can ask a mix of homework questions or concept questions, but otherwise I'll just go ahead and just merrily go along here. And by the way, for the questions that I think I've addressed before in previous videos, I may refer you to those videos, and then I might address those at the end. All right. So I may have a bias towards new questions today. All right. Okay, this is new, 356H, the very last problem. And folks, as I emailed you, remember that these are required, okay? These are required. You have to do these. Okay. The additional problem piece was only for part C, right? Okay, these are all required. H is the very last problem. All right, so 356H, it's this last one. All right, and I think I'll go ahead and keep using my homemade whiteboards here. Oh, that's already a good thing there. All right. All right. Okay, so I'm gonna give you some time to rename this. So this is a 346H. All right. Okay, so and it is that one, right? Okay, all right. All right. Obviously, if I make a mistake, let me know. Yell at me if you have to. All right, so this last one here, all right, and you got to show all work. So of course, answer only might be a bad idea for these. If you just give me, I mean, come on, I give you the answers, right? So you want to show work on these kinds of problems. I reserve the right to give no credit if I really need work. Okay, so I'll keep doing this in green. So here's a given problem, all right? Now, if that were a 0, it might be a different strategy, but that's a 1. So why don't we start by condensing and using the product rule? All right. All right, so let's use the product rule. The sum of logs, I'll type this out. Reversing the product rule. The sum of logs is the log of the product. We're reversing the product rule. Okay, so we have here the log, the natural log, ln. Okay. By the way, some students put an e here. That's not good. Just leave it as ln. All right, ln of, all right, the product, which I'll write like this. Right, x plus 1 times x, all equals 1. All right. And then it's up to you. You can either multiply these now or later. I'll multiply them now. Okay. Don't put an equals here, by the way, because we have here equivalent equations.
Rồi muốn đẻ mà đi kiếm thằng khác đẻ cho ông nào. Cái gì? Excuse you? Ừ.
All right. ln of x squared plus x equals 1. All right. Now, at this point, instead of ln, you might want to put log base e. But remember, it's either ln or log base e. And in the end, in a final answer, we prefer ln, by the way. Okay, so we can write ln as log base e. I know a lot of students like to do this. They like to write ln base e, but that's very redundant. We don't like seeing that. All right, log base e of this, x squared plus x, equals 1. Oh, yes, I remember this problem. Yeah, a lot of students asked about this problem. All right, now I'm going to go to exponential form, the zigzag. Okay, remember how the zigzag works? Okay, e to the first equals that. All right, so going to exponential form, okay, e to the first equals, it's good form to line up the equal sign. Okay, I'm having a hard time aligning though with my mouse, but e to the first equals this thing here, or that. You know, you can multiply now or later, but x squared plus x, right? It's e to the first, so you don't need the 1 there, right? Okay. All right. Now here's the thing. What if that were like a 2 or 3 or 4, right? Well, you'd want to isolate a 0. You want to isolate 0. So subtract e from both sides. X squared plus x minus e. There's no way you can factor that old school because negative e or the opposite of e, that's an irrational number. There's no way we're going to factor this thing old school. You got to go to the QF. You got to go to the quadratic formula. All right. So from the quadratic formula.
Okay. Yeah, that's where I got stuck when I got to this point, and then I was trying to figure out how to factor it.
Oh, there's no way of doing it because that's not even an integer, right? So yeah, you got to use a quadratic formula. Oh yeah, so that's why h is kind of freaky. But folks, you know, in calculus, you know, sometimes you will use the quadratic formula with really messed up constants like negative e or opposite of e. So I want to psych you into that in this problem. All right, I'll cut to the chase. So x equals. All right, I'm not going to do the general form. I'm just going to go straight. The okay, well, I encourage people to go, yeah, a equals 1. Yeah, I'll do that. A equals 1. Whoops. A equals 1. B equals 1. And C equals this weird number opposite of E or negative E. Okay. And remember, you have to subtract E from both sides. You have to isolate 0, right? Because you're finding zeros of this quadratic. All right. So opposite of b, so opposite of 1, that's negative 1, all right, plus or minus the square root of the discriminant, which is a totally messed up number, right? Okay, so it's b squared, that's 1 squared, or 1, you know, b squared minus 4a, I should type this, 4ac, the negative e, or opposite of e. All right, all over 2a. All right, quadratic formula. Okay, very messy expression. Equals, all right, so it's going to be negative 1 plus or minus the square root of, this ends up being what? 1 plus 4e, right? 1 plus 4e, or 4e plus 1. Okay, and there's no way of simplifying that radical. That's just a messed up radicand. All over 2. Okay, now here's the thing though. Are these both solutions? Consider the issue of checking, right? So take these guys and plug into here. Now, remember, the key check is to make sure that you're only taking logs of positive values, right? Okay, well, here's, okay, now here I have ln of x, right? Okay, well, right off the bat, if you take the minus case, right? If you take the minus case, you're going to get a negative number, right? That's going to mess you up right there. So the minus case, I'll type this out. The minus case is definitely dead. Okay, reject the minus case out of hand, because if you use the minus case, you get a negative number, and then that means you're trying to plug in a negative number here, and you're taking the log of a negative number. That's no good. You reject. Okay, now in the plus case, look what happens. In the plus case, if you take this number and plug in, the positive one, okay, now, gosh. Let's consider the plus case. In the plus case, we have negative 1/2. I'm breaking the fraction. Negative 1/2 plus the square root of 1 plus 4e over 2. Okay, so doing a quick sign analysis here, right? So we're going to put that, and if you plug into x here, right, when you add 1, when you add 1, this is going to flip to a positive 1/2, and that's positive. So with the positive case, at the very least, you know that the argument here is going to be positive. So I'll be happy with that for now, okay? I'm not going to trick you in any other way. Okay, so for this case, we're going to accept. Now, technically, we should really plug in and work it out, but the fact that this makes both, the fact that it makes both these arguments positive, that's good. By the way, this itself is positive because this is negative 1/2. That's positive in here. This is negative 1/2. This is going to be a bit more than 1/2. It's going to be more than 1/2. So you know this thing's going to be positive. All right. So it also makes this argument positive. So yeah, a lot of it was sign analysis, right? Making sure that if you plug this in for x, x is positive, and so is x plus 1. So the check is the big thing. In any case, this is the only solution. Okay. Basically, you kill the negative. You kill the negative. Hold on a second. Let me get the answers. Yep. So either split up or combined. You can leave it combined where you kill the minus. Negative 1 plus, you kill the minus. Negative 1, I'm going to do this. There we go. Negative 1 plus sign, only the plus sign. Root 1 plus 4e all over 2. All right. So a couple of things here. First of all, the recognition that you can use the QF for messed up constants like these, because old school factory is not going to work, but the QF will work as long as you have real coefficients, right? And also the recognition that both x and x plus 1 are positive for at least the plus case. You reject the minus case. But this is a good problem. This gets you really thinking about algebra and signs. Good problem. Of course, I'll say that about my baby problems. All right. Any further questions about that? Any further questions? All right, I'll save this. Good to keep this saved. Don't want to lose my solution. Yes, question?
I was just saying thank you.
You're very welcome. Yes, I'm sure many, well, you know what? Half the students are scratching their heads like you. Half the students haven't even gotten here, right? All right, bravo. All right. Next up. All right. Okay, so okay, oh yeah, so I'll go to 2, 2, 9A, and 9B. All right. Sometimes I wonder how to order the problems here. So Liam, if you could give me a particular a problem in 6, then maybe we can address that. All right. But let me go with 2, 2 for right now. By the way, if you don't want me to use your name in the recording, please let me know. Okay, all right. Okay, so 2, 2. Right, 2, 2. I like this one. Yeah, I love the concept ones because it's a strain of my hand, right? It's thinking. 2.2, which can be straining. 2.2, number 9, AB. Right. Okay. So I've given you this this function rule this polynomial function rule in basically LFT form, right? You have the constant leading coefficient, okay, and basically you have LFT form over here. Nice factorization. All right, so use the ideas of this section to graph f. Oh, this will be fun. I love this problem. All right, you'll not be able to locate some of the turning points exactly, because then use calculus, right? You tend to use calculus to find the local max and min points. Yeah, this will be fun. All right, all my problems are fun. All my problems are fun. This will be special fun. All right. But you know that all my problems are fun. All right. That's why you're here, because my problems are so much fun. I'll put this in blue. Mix up the colors. All right. I have the right to name my thing here because I want to reuse it. Yeah. All right. So first of all, again, this is a 2.2 number 9. Type that out here. Also, check my header. If you can see, check my header. 2.2 number 9. All right. Okay, now take a look at this factorization here. Now, if you were to multiply it out, now trust me, that'll take you some time. And frankly, I don't know if I can get it right in one fell swoop. But at the very least, what's the leading term? If you were to consider multiplying this out, what would be the leading term? All right. Well, we're going blue, right? Okay. So we basically get y. Whoops. Y equals. All right. What's the leading term? 1/30. Now, if you multiply this guy out, the leading term is an x squared. Leading term here is x. Leading term here is x. X squared times x is x to the 4th. That's the leading term. And then I don't care so much about the lower order terms. But this is key. If I care about one term, it's that leading term. The constant term would give me the y-intercept, but that's of questionable value. But yeah, I like the fact that I know the leading term. That's huge. Okay, when I do something like this, I'm implying that these are lower order terms here. All right, which means overall, what's this graph look like in the long run? What does this graph look like in the long run? And then we'll ask Desmos to give us a much nicer graph. This is gonna be sloppy. All right, so overall it's gonna be an upward opening bowl. It's gonna go up, up this way and up this way. Now, folks, don't worry. You don't have to graph this too accurately, but give me a sense of how it's acting, and especially around the x-axis and long run. All right. Now, we can tell the zeros, right? Based on this, what are the zeros? Well, they're all real zeros, right? They're all going to be real zeros, and they correspond to what points on the graph? The real zeros of a function, y is a function of x, corresponds to what points on the graph? They correspond to where this is 0, where y equals 0. These are the x-intercepts. Where? At -3, 0. At +2, 0, and at +5, 0. So we're going to get x-intercepts here. And what's happening? Oh, and by the way, if you plug in to get the y-intercept, if you plug in 0 for x, you can probably figure it out. You get 9 times -2 times -5, 3. Zero comma 3. Okay, 0 is pretty easy to plug in here. All right. So graph is coming down from the heavens. Coming down from the heavens. All right. All right. Cheat with my mouse. All right. So the graph's coming down from the heavens. We get this point, and what's happening? See that 2 there? The multiplicity of the 0 there at -3, multiplicity is 2. It's even. What's the graph doing? Cutting or bouncing? The graph is bouncing. Now, here's the thing. I don't know where this graph turns. Does it turn in quadrant 2 or quadrant 1? I don't know. That's a calculus problem. So don't worry about that. Okay, let's say it turns around here. Who knows? It might even turn at the intercept. Okay, again, the turning point could be here, actually, right? Okay, but we hit this point. Okay, we go on. It's only 4th degree, so it can't be too wavy, right? And then we hit the the x-intercept here. Now, the multiplicity here is just a 1, so we cut kind of linearly. We turn around somewhere in here, don't know exactly where, but somewhere between 2 and 5, and then reach the x-intercept at 5, 0. Again, the multiplicity is 1. We cut like a line practically, and we go up, up, up. So that's about as good as we can do as a pre-calc student, right? But Desmos is wiser. What does Desmos say? Desmos is much more beautiful. Okay. But folks, don't cheat. Don't just use Desmos, right? But I also gave the answer in the back, but okay, we're trying to figure out why this is. I want to move this toolbar. Okay. All right, so y equals, well, it's factored form. That's fine. Y equals 1/30. Although as far as the 1/30 goes, it only affects the scaling and the y-intercept, right? The x-intercepts are the same. 1/30 times x plus 3 all squared times x minus 2 times x minus 5. All right, look at that. Okay, we did a pretty good job of that. Okay. Oh, and it turns out, look at this. The turning point is actually at the y-intercept. Okay, so it didn't turn around in either quadrant 1 or 2. Right, so my bad. But I wouldn't mark off on homework or on a future exam for future classes. Okay, you won't know that till calculus. All right, anyway, but what's the graph doing? Overall, it's an upward opening bowl, right? Overall, it's an upward opening bowl in the long run. Comes down from the heavens at -3 at the -3 comma 0. That x-intercept, the graph bounces. Okay, it turns out that it looks like it's at the intercept. Yeah, it looks like it's a 0, 3. Yeah, we won't know till calculus. That's the y-intercept if you plug in x equals 0, right? And then we have the next x-intercept at 2 comma 0. Cuts. Okay, got to turn around somewhere in there. You don't have to locate this point, but it'll be somewhere between 2 and 5, right? In x. And then 5 comma 0. Cuts and goes off to the heavens. All right. So aside from the exact location of the turning points, now that's a turning point, though. Know that you have a turning point at -3 comma 0. You got to know that. But the fact that that's a turning point and where the turning point is here, that's for calculus. All right. But even though I messed up the even though I didn't locate the turning point properly here, I couldn't exactly find this. Pretty good, right? We made a pretty good prediction here. Any questions? Any questions? And we're recording, right? I'll cry if we're not recording. So if you hear me go, wah, ha, 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 it means that I'm not recording. I'm recording. Any questions? All right. Oh, and B. What's B? Find the signs. But here's the thing. Once you get a good indication what the graph looks like, you can figure out the signs for various functions for all values of x. So f of -4. I'll do this in what? Green. F of -4. Look, -4 is over here. The function value is positive. F of 0. Well, f of 0 is 3. We know it's positive there. F of 3, it's negative. Oops. F of 3 is negative because the y-coordinate is negative over here for x equals 3. F of 6 is going to be positive because x equals 6 gives us a positive y-coordinate on the graph. So come on, if you do a decent graph, then you'll be able to find the signs of these for all real values of x in the domain. All right. The function values are positive if you're above the x-axis, negative if you're below the x-axis, 0 if you're hitting an x-intercept. Check to see that. So I guess I had you plug in and then check to see that your results are consistent with your graph. Okay, but what you can do is you can plug these numbers in directly, right? Okay, I won't do that. You can do that yourselves. I did f of 0. That was 3, positive 3. All right. Any questions? I'm checking the bottom also. Any questions? I love that problem though. That's a good concept review. All right. You see, I like my homework problems. To me, it's better than, my math lab spinning up random problems at you. At least Alex is AI, deep AI. All right. Okay, so let's go with the 3, 4, 3, 5 block, and I'll entertain, especially let's do one for now. One more for now. Let's see, 6. D. 6D. So again, that last block there, 6D. A lot of students didn't even know that was required. 6D? Wait, 60, we did that. Yeah. Oh yeah, my math lab. Oh yeah. There's my math lab and there's WebAssign. I've never used those, but we have hardworking part-time instructors and they rely on those homework systems because they do like, oh, here's some random factoring a QT problem, right? Uh, we did H night. No, I did D another night. Yeah. Oh, okay, yeah. So what I'm gonna do is I won't leave it hanging. I got the notes. In fact, I think it was the one that I forgot to file away. I'm glad it's here. I think I have it right here actually. It was the one I didn't file away. I think I have it. Where is it? Here. Yeah, it's the one I didn't file away. I have this one. Oh no, that's hey, that's F. Hey folks, that's F. Hey folks, you need F? That's F. You want to do F quickly? This is F. Let me retitle this. Okay, well I have this up here. This is F. It's in my YouTube page. I'll just quickly go over this, right? Difference of logs is log of the quotient. Oh, wait a minute. Wait a minute. Wait, this is a F. Yeah. And there's a 1 over there. Difference of logs, if that were 0, we could separate, but that's a 1. Difference of logs is log of the quotient. 2 to the first is that guy. Then you got to do algebra, folks. That's the hard part. Algebra 1, right? Multiply both sides by the denominator, distribute, all right? And then you got to basically subtract and add stuff until you get to x equals 3. All right. So that's in the YouTube video, I think from Tuesday. So you can check the end of class, after class for that. But those are my notes there. If you want to do a screenshot, I'll give you 10 seconds to do a screenshot. Do screenshotting. That's F. Hold on. All right. 10 seconds to do a screenshot. Questions? All right. That was F. But I could do another one of these from scratch. D, for example. D. I don't think I haven't done that one yet. Let's do D. 6D. So 6D. Let's do 6D. All right, that's not too bad. Let's do 6D. I'm gonna save this with a proper name. All right. Let's do this one. Okay, D. Let's do that in red. I hope that doesn't trigger you. Purple. Yeah. Some people think that red triggers people. Okay, let's go purple. D, 6D. Oops. On 3.4, 3.5, right? All right, now here, that's one of the nicer ones because we have a 0 there, right? That helps us a lot. There's a 0 there. And we can separate the logs nicely. I'm going to add this to both sides. Separate the logs. In fact, I can even type this one out. One of the few that I can. All right, so log, that's a common log, base 10. Log of 9x minus 2 log of x plus 2 equals 0. All right, I can then go, whoops, log of 9x equals 2 log of x plus 2. All right. Now I'll turn on my pen. All right. What can I do with this too, folks? Time to play basketball. Power rule. Log of 9x equals, okay, because you don't want to have to square that thing, right? No, I'm sorry. We are going to square it actually. Okay, I'm thinking in reverse. Log of x plus 2 all squared. Okay, we are going to square actually. So you may not want to do it, but we're going to do it. All right, and then what can we do? Log of m equals log of n. We can drop the logs. One-to-one properties. Boom, one-to-one properties of common log. 9x equals, oh, I'll put a bracket here. The square of x plus 2. And at this point, the hard part is the algebra 1. Okay, so you got to review your algebra 1. 9x equals, what's the square of x plus 2? Is it x squared plus 4? Is it x squared plus 4? I hope I hear coughing. Nope, don't miss the middle. Twice the product of 2 terms. 4x. X squared plus 4x plus 4. This PST. When you square a binomial, you get PST. Okay? Or do x plus 2 FOIL. All right? Now, we have an x squared term, x terms, and a constant term, non-zero constant term. So let's isolate 0. Let's subtract 9x from both sides. Isolate 0. That's a good strategy. Isolate 0. 0 equals x squared minus 5x plus 4. That's a cutie. It's readily factored. That's where my math lab comes in, right? Practicing that stuff. Or Alex. That's a cutie. You can factor it. Or you can use a QF the long way, right? X here, X here. If it works, both same sign, both minus. 1 and 4. That works. Now, are these both solutions? 1 and 4. Well, let's see. Let's look up here. I think so. Because x equals 1 and x equals 4 make these both positive. That's a good sign, literally. So I'm going to guess they are. I think they're both solutions. Again, we should technically check, but I feel good about our guess here. I wouldn't mess with you in that sense. All right. Say goodbye to Desmos for now. I hope that's the answer. Yes, I got my own problem right. I'm so proud when I get my own problems right. All right. Questions? Questions? Okay, these were required. Okay, D through what? H, they were required. It was really, okay, so I was going to say wishful thinking, but the way it's formatted, I can see why students thought that these all counted as additional. Normally, additional means optional. And here, this was the additional piece to part C. So this is required, but the relaxation of the assumption is the additional part. These are still required. D through H are still required. And of course, problems I do in class may be more likely to be graded. That's why you come to class.
So a question on that. So is the additional problem for C optional?
It is optional. It is optional.
Okay. Just,
now,
just that part of it, though.
The reason, no, I'll explain what happens. If you relax the assumption, when you smack down the 4, you have to put absolute value. That's the difference. Yeah. But see, some students get creeped out by that, and I didn't want people to get hung up on it. So for students who felt confident about this material, go for it, and you have absolute value here. Do you remember how to deal with that? But you know, if you're pressed for time, you just got to get this darn thing in. Then don't worry about it. Don't worry about the additional. Don't worry about this. Worry about D through H. I mean, you got to do these things in calculus. So these are required. Okay. So there's no excuse. Yeah.
One question about the brackets and the parentheses on C. What's the purpose of I've seen a couple of the problems where they have the brackets like that. What is?
Oh, okay. Now I really want to emphasize.
I would think that it would still work without those brackets.
That's a really, really good question. Because here's the thing: if you have something like this, ln x to the 4th. Okay. I mean, years ago I thought, well, practically all books would treat this as ln of, and x to the 4th is the argument, right?
Mm-hmm.
And in fact, I still tend to think that. But if you go to wolframalpha.com, they treat this like this. And their rationale is that they say that function operators precede exponents. And that's a reasonable thing to say. That's a reasonable thing to say. So I'm not ready to call it wrong. That's why over time, if the argument is something other than like x or t or theta, I tend to use grouping symbols.
Gotcha.
Right, right. So when in doubt, use grouping symbols. And let me tell you something. One of the most surprising things I've found in teaching pre-calc is that grouping symbols come up all the time. That clarity is helpful throughout the whole class. All right. Any questions before we proceed? Any questions before we proceed? All right. So we've done what, like 3 down here, basically. Great. Maybe you're logged out. All right. And you'll log off maybe. Let's see. 2.3 10b. That sounds familiar. 2.3 10b. I hope I'm making you dizzy, but if you made it through that Pythagoras video, you make it through this. All right, 2.3 10d is this one, right? Yeah. Yeah. Oh, yeah. Okay. Now, I'm sure I've done this before, but I'll go ahead and do it from scratch. Okay. Although I have done this before. All right. Well, you know what? Maybe I don't want to waste your time. You know what? I'm going to try to locate this. I did do this before, but I'm going to go ahead and try to locate this. Okay. It's 2, 3, 10b. Okay. Because I can just go over my, you don't have to wait for me writing. It's probably in a previous video, but I'm not sure. It might have been office hours. I should have opened this early on. 2, 2, 2, 3, 10b is this one, right? Yeah. Okay. So I did this in either office hours or after class. But here's the solution. I'm going to go through the solution. All right. Feel free to take a screenshot. All right. 2, 3, 10b. 2.3 10b. All right. So we have here f of x, this big ugly guy. Imagine that it's written in descending powers, though. All right. Divided by 2x plus 1. All right. Equals. So f of x divided by. So I gave a hint here, right? Hint, factor the leading coefficient out of the divisor. So when you factor 2 out of the divisor, when you factor, you divide, you get 2 times the quantity, x plus a half. Okay? Now, the 2 comes out not as a 2, but as a 1/2. All right? If you have a 2 in the bottom, it pops out as a 1/2 overall, right? Times f of x over x plus a half. And then you've performed synthetic division on this thing. Any questions so far? Any questions so far? All right? You perform synthetic division on this. X plus, you're dividing by x plus a half. That's a divisor. Remember, you flip the sign. You put negative 1/2 in the dunk tank, the 0 for that divisor. All right? The coefficients, remember, you should write this in descending powers. 6 is the leading coefficient, then 5, then -1, then 4. Okay? There are no missing terms. How's synthetic division go? K is negative a half. Bring down the 6. Multiply by K. Add. Multiply. Add. Multiply. Add. Synthetic division. So then you get 1/2 times. This is a third degree. If you divide a third degree by a first degree, you get a second degree. These are the coefficients in row 3 of the synthetic division. 6x squared plus 2x minus 2. Plus, that's not a 0, we get a fraction here. The remainder is 5 that goes over this divisor, x plus a half. And then, don't forget, there's a 1/2 in front of all that stuff, right? There's a 1/2 in front of all that stuff. Put brackets or something, or parentheses, okay? Then you distribute in the 1/2. So you get 3x squared plus 1x minus 1 plus, and then when you push in the 2, you're reversing this process. When you push in the 2, you get 2x plus 1 back. 2 times that is 2x plus 1. Done. So that shows how you can use synthetic division if the leading coefficient of the divisor is not 1, but still linear. It's a hack. You do some factoring, all right? And then once you've done this process, you distribute this piece back in. All right. Oh, good. Thank you for letting me know, because could I repeat any of that? Because I cannot blame you at all if you thought that was too fast. I probably did this in office hours, or I did this in the after class hours, and I took the time to write it out. One benefit to me writing things out is that it slows me down. Okay, but I think a lot of you got to hear, I think, and then you didn't know what to do. I don't blame you, and I think it's the idea. It's the idea that gets people. Right. You can see why it's good I saved these things. Any other questions on this? Any follow-ups? Because this is a popular or unpopular problem, as the case may be, on the homework. All right. Two, 5, 4. Oh, but ready to go on, right? If you say no, all right, let's go on. All right. Okay. Okay, so 2, 5, oh, oops. Okay. Oh, you're welcome. 2, 2, 5, 4. Yeah, big one, 2, 5, 4. Yes, yes. Many students had trouble with these, right? Because you might know old school factoring from chapter 0, but we're factoring over various sets, not just Z. And the request is for 4, but we can do others later. Put this in purple. You know, I think I have this also. That helps because, you know, doing all this mouse writing, it can be kind of tedious. Let me see if I have it. Yeah, I have it right here. It's right here. Wow, I'm so glad I saved these. Because I'm assuming you just kind of maybe got stuck somewhere, right? Okay, so here's the deal. X cubed plus 5, all right? We're treating this as a sum of 2 cubes. Sum of 2 cubes. We factor it as a binomial times a trinomial, all right? To get the binomial, x cubed is the cube of x. To get the constant here, 5 is the cube of what number? 5 is the cube of the cube root of 5. All right. S here is for same sign, plus. All right. For the trinomial, I like to build off the binomial. The square of x is x squared. O for opposite sign, instead of a plus, we have a minus. You take the straight product, the cube root of 5. It's good to put that in parentheses times x. Otherwise, if you don't have the parentheses, make sure your radical does not extend over the x. Make super sure of that. AP for always plus is a SOAP problem. AP for always plus. Then you take the square of this. Okay. Now the square, you can tuck that into the radicand. The square of 5 is 25. That does work. The square of the cube root of 5 is the cube root of 25. If you now this is also 5 to the 1/3 over here. If you put 5 to the 2/3, I'll also accept that. Okay, this is typically prime. The GCF was 1 already, and then these are typically prime. We're done. All right. Questions? Would anyone like me to slow down on that? Any questions? Any questions? All right. Any questions? Okay, so I'll leave this. It's in my notes anyway. So, okay. Oh, you're welcome. Let's see. 2.2. Oh, yeah. Are these the long run ones? Yeah, 2.2 number 1. Okay, what's the flavor of these? Okay, but I love these. These are more concept ones. So we focus on the leading term as a zoom out property. In the long run, how do these things act? Here, the leading term is 5x cubed. How do you graph y equals 5x cubed? It's a rising snake. Now, these lower order terms may put, that thing in particular may put a bump in there, but I don't care. I don't care about bumps, right? I care about long run behavior. In the long run, we're talking about a rising snake, positive 5x cubed. These are lower order terms, rising snake, which means the limit as x approaches infinity, going up, is going to be infinity. As x approaches negative infinity, down, we get negative infinity. Do you see what I'm doing there? I'm asking what are the y coordinates approaching as x approaches positive infinity and as x approaches negative infinity? For these bulls and snakes, you're either going to go up towards positive infinity or down towards negative infinity. You see what I'm doing there? Any questions? Any questions? All right. So do you see what I'm doing there? Okay, now, let me see here. Any questions? I can do another one. Any questions? That's the flavor of the problem. Any questions? All right, I can come back, but that's the flavor of the problem, right? Basically, bulls and snakes in the long run. Okay, 3, 4, 1E, I see. Okay, 3, 4. Right, exponential equations, 3, 4, 1e. We begin with e. Let's go to blue, 1e. Ah, yes. Okay, another one that students ask for quite a bit. Okay, so I would, you know what, I'm going to get another whiteboard up. Let me save this, by the way. Yeah, let me save this one, 346D. You can see why I want to save these. Okay, I'm going to save this one. All right. All right. Okay, this is 3.41e. Okay, hint factor. Now, first of all, my first hint is to actually do a substitution. Let u equal e to the x, that middle guy there, right? U equals e to the x. It's kind of similar to quadratic. In fact, this is in quadratic form. This is in quadratic form if you do this substitution. U equals e to the x. If you do that, what's u squared? U squared is going to be e to the x all squared. I know it's funky looking, but when you raise a power to a power or exponent, what do you do to the exponents? You still multiply them. U squared is e to the 2x. Which means that when you apply these substitutions, this guy becomes u squared, that guy becomes u, all right? And we now have quadratic form. We get 2u squared minus 13u plus 15. It's in quadratic form because when I do the substitution, I can get a QT in u, a quadratic trinomial in u. This equals 0. Now, if I'm in a really bad mood, you'd have to use the quadratic formula. You still could, but it turns out this factor is old school. I wasn't that mean on this one. Ah, substitution. Folks, things I want you to carry with you till your grave. Grouping symbols and substitution. So when I'm like 200 years old and I'm attending your funeral, I'm eternal, I want to hear you gasp, grouping symbols, substitution, all right, as your last words, and then I'll be happy. All right. So all right. 2u and u. You're hoping teacher's nice and this does work over the integers, right? Same signs, both minus. 5 and 3. See, teacher knows that teacher wanted to play nice here, so it worked out pretty nice here. All right, nicely. Okay, bottom line, you want to set these equal to 0. I won't waste your time. Here, from here, u equals positive 3/2. Not that I don't make mistakes also. Here, u equals 5. We're not done yet. Okay. Because to almost quote AC/DC, who was u? U equals e to the x. Equals 3/2. Or e to the x equals 5. All right, a key principle when solving these exponential equations. What gets rid of e? What function gets rid of e? What kind of log? This guy. Natural log. We're going to use the inverse properties. Ln of e to the x equals ln of 3/2. I like to loop my L so they look like ones. Or having a hard time typing here. Okay. What's ln of e to the x? What is ln of e to the x? By the inverse properties, it's just x. X equals this guy. I won't type him again. I'm being lazy. X equals this guy. right, notice they were taking logs of positive numbers, so we're good. If these were negative, we'd be dead in that branch. So I think these are both solutions, right? 3/2 and 5. 3/2 and 5. Solution set. You don't have to put them in order, but 3/2 is lesser. You don't have to put these in order. I believe these both work. Did I get my own answer right? I sound so silly when I. Yep. Whoa, ln. Oh, my bad. I should have done the squiggle. ln. ln of 3/2, right? ln of 5. Okay, so I would have marked myself wrong. Gotta put the ln's. I'll put grouping symbols for good measure. Good thing I checked. Okay, so I can do squiggles. Don't be too lazy with the squiggles. Then you do what I did. All right, x equals the solution set, ln of 3/2, comma, ln of 5. There you go. And I don't care what order you put these in. I think, okay, now I think this is a negative number. That's a positive number, but at this stage, that's okay. All right, save this one. Okay. Students often ask the same types of questions, so these will help me years from now. All right, now, oh, okay, so on D, try this. Try D like right now, okay? It's a similar idea. Let u be e to the x. It's not even a cutie, just factor out a u, right? But it's very similar in flavor. So let u be e to the x, all right? It's a more basic quadratic. You would factor out a u and then go from there. I think you get a point where, you get e to the x equals 0. But the problem is that 0 is not in the range. Also, the ln of 0 is 0. So that's a dead end. I think what happens in D, that's one of the branches, but that turns out to be a dead end. So you cross it out. The other branch does survive, though. All right. Any questions about 1D and 1E? Again, I can go back to D later. Any questions? All right. Where are we? 3, 4, 1E, we did that. So D 332D. Okay, I think we're at 332D. But please don't be offended if I'm not getting that right. But okay, 332D. Yeah, if I skip you, please don't be offended. It's kind of hard in chat to know who's next, right? Okay, so let's do that one. 332D. All right. I'm gonna get a new. Yeah, I haven't done this yet recently, so not on my whiteboards. By the way, in case you're curious, I love these. What I do to make these is I open up a huge blank text file. I take a preview screenshot of it, right? I take a preview screenshot of it, and then I eventually save it as PDF. Then you can do all sorts of magic with it with the markup toolbar. That's what I've been doing. It's been great. You can work on prior PDF files. That's what I've been doing. All right. So just basic tools. All right. 332D. 3.3, 2D, and I'm going to title this. All right, so here's a given problem. Okay, now you could do it really step by step. Okay, so but by doing this step by step, you could do step by step, but I'm going to skip some steps here. I'm going to skip some steps here. In fact, I'll admit for D, I'd accept answer only. Now, a student might say, well, I thought that you wanted us to show work. Well, I'm telling you right now in class that by the time you get to calculus, it's expected that you be able to do something like this automatically. So I'm telling you in class right now, answer only is fine. Because by calculus, a calc teacher may expect you to do this in one fell swoop. All right? But I'll talk it through with you. Okay? So basically, factors of the top will have plus signs in front. So we're going to have, okay, I'll just do it straight off. Oops. All right. So we have log of 10,000 as a common log, all right, plus log of a to the fifth, but that 5 is going to smack down by the power rule, all right? We get that. And we're assuming that a, b, and c are positive, so you don't need absolute value. And then the factors of the bottom will have minus signs in front. So minus log of b cubed, but the 3 smacks down. Okay. And then c to the fourth is on the bottom, minus log of c to the fourth. But again, the 4 smacks down. Now I'm going to do this again, all right? And then you realize log of 10,000, okay, you're asking, it's log base 10, right? So you're asking 10 to the what is 10,000? 10 to the what is 10,000? You're basically counting zeros, right? 10 to the first, second, third, fourth. That's 4. So you want to put a 4 here. Okay, so very often a calculus student would approach it that way. But I will go over it in more detail in just a minute. Okay, so 4 plus 5 log A minus 3 log B minus 4 log C. All right, and again, I accept answer only. But I'll do this in case you're going, wait, that's way too fast, and I don't want to see the shortcut. Okay, so let's do this in more gory detail. I'll do this in a different color. I'll do it in blue. Okay, so how do you do it the long way? How do you do it the long way? All right, so that guy there equals, okay, the log of a quotient is the difference of logs. Okay, log of 10,000 a to the fifth minus log of b to the third, c to the fourth. So a conscientious student who didn't feel comfortable with the shortcut minus log b to the third, c to the fourth. All right. And then, so we've used the quotient rule. The log of a quotient is the difference of logs. Now, we're going to use the product rule for both these terms, all right? The log of a product is the sum of logs. The log of the product, I'll type it out. We're doing the product rule, all right? The log of a product equals not the product of logs, but the sum of logs. The log of a product is not the product of logs, it's the sum of the logs. All right, so we have log of 10,000 plus log of a to the fifth. These are common logs. It made things convenient. But if there's a base like 3 or 5, put that in. Plus log of a to the fifth minus the log of a product is a sum of logs. Log of b to the third plus log of c to the fourth. The log of a product is the sum of the logs. Now, I have a question for you. Is this correct? Is this equivalent to that? Is that correct? Or do I have to do something? Well, a lot of students do this, but careful. Grouping symbols. Remember that all of this breaks up as that sum. And when you have something that consists of more than one term, especially when you're following a minus sign, be prepared to use grouping symbols, okay? That's why eventually that flips over to a minus, all right? Careful. This is one of the most common, this is by far the most common error, the sign error over here, or failing to use grouping symbols. Okay, so proceeding. Similar to my argument over here, log of 10,000 is still 4. So I explained that up here. Log of 10,000 is 4. You have to note that. Plus the 5, the 3, and the 4, they all smack down. 5 log of A. In fact, at this point, well, yeah, I can just copy this. Copy this. But instead of log of 10,000, we know now that it's 4. All right, so it's 4 plus 5 log of A minus 3 log of B minus, by far, that's the most common error. Minus 4 log of C. Watch the grouping symbols, watch the signs. Any questions? Any questions? Okay, 3, 3, 3, A to C. Okay. So C kind of reverses what we did before. Let's go to A. Okay, so let me see. Let me ask a question here. So I'll do one of these before the break, and then so I'll do one of these, and then we'll take a break, 10-minute break. Then we'll come back and maybe do some others. Any preference? Because C's like reversing what we did before almost, and then A is more elementary. Well, I mean, I may as well do both, I guess. Oh yeah, let's do A. Yeah, okay, let's do A. Okay, so. Okay, 3, 3, 3, A. 3, 3. All right, let's do some green. Well, brown. 3, 3, 3, A. I like using different colors. If you get bored, use different colors. I sound like a 5-year-old. All right. Okay. So here's the given expression, condense. Okay, and we do this when solving equations because we like having log of something equals 0, for example. All right, so your first step here would be to use the power rule in reverse. Throw these coefficient things up as basketballs. This goes up, and use grouping symbols. That helps. Okay, so then we get, equals. This thing equals, all right, log base 3 of x squared. Okay, and the grouping symbols helps to indicate the argument. I think it's great to indicate the argument. Plus log base 3 of y to the 4th. All right, we have here a sum of logs. Sum of logs. But the sum of logs is not the log of the sum. It's what? It's the log of the product. It's the product rule. The sum of logs is not the log of the sum. It's the log of the product. All right, so equals should be the answer. Log base 3 of x squared y to the fourth. Okay, that should have been my answer. Yeah, log base 3, x squared y to the fourth. Obviously a nicer typeset as opposed to my chicken scratches. All right. Okay, well, right now it's 8:12. Let's take a 10-minute break. I won't abandon you. Let's come back at 8:23, okay? In the meantime, you can put some more questions in the chat. But let's take a break until 8:23, all right? All right. Okay, so I'll see you then. Some of you might not be back, but I'll see most of you then. All right. So let's pause. Let's mute it. I moved my toolbar. I remember that. Okay, so 259. I think I skipped over. All right, so 259. All right. Let's see. Yeah. Okay. So 259. Okay. Let's see. Brown. Different color. Purple. Let f of x be x to the fifth minus 4x to the fourth plus 4x cubed. Right. All complex zeros of f and their multiplicities. GCF is x to the third. All right. So this is x to the third times. All right. When you factor your divide, x squared minus 4x plus 4. Whoops. And that is a PST. Okay, that's a PST. Perfect square trinomial. We get x cubed times, that's the square of what? Square of x minus 2. All right. So what are the two distinct zeros here? The two distinct zeros, in fact, they're integers. Okay, they're complex, but they're also integers, 0 and 2. 0 is a 0 of multiplicity. The exponent on the x is 3. 2 is a 0 of multiplicity 2. Notice that the multiplicities add up to 5. It's a fifth degree polynomial. The zeros are 0, 0, 0, 2, and 2. That's my answer, right? Yeah, that's right. All right, questions. All right, and then I think all the way, yeah, 263, 275. All right, so 263. I'm recording, right? Okay. Okay, 263. Please remind me if I'm not recording. We are recording. All right, 263. Oh yeah, concept problem. But these are the hardest ones, right? Okay, so we have this. Okay, and using long division, we got this. Here's a quotient, remainder over divisor. Consider the graph of either y equals that or y equals that. Given equation of the slant asymptote. Okay, identification. Y equals the quotient. That's it. Y equals 3x minus 5. It's an identification problem. Yeah. The idea being that in the long run, this piece here, as x approaches infinity or negative infinity, that approaches 0. Because if you did the long division correctly, you either get 0 here or a bottom heavy guy, which approaches 0 in the long run. In fact, for kicks, why don't we do this? Let's go to Desmos. Desmos. Yeah. There we go. He's hiding. He's working too hard. He's hiding. All right. Y equals 6x x cubed plus 2x squared minus 7x minus 16 all over 2x squared plus 4x plus 3. All right. Well, look at this guy. In the long run, looks like a line. In fact, if I were to graph y equals 3x minus 5, okay, check this out. If I were to graph y equals 3x minus 5, gotta move my zoom boxes. Y equals 3x minus 5. Voila. Flashing it. Right? Just look, there's a little bit of a discrepancy near x equals 0 here, but in the long run, they look a lot alike. All right. Oh, yeah, yeah. And in general, whatever this polynomial quotient is, then it'll be the long run behavior. So for example, if instead of 6x to the third, I had 6x to the fourth, then in the long run, it's going to be a bowl. All right. All right. Let's see. And there's another one that was requested, 275. Yeah, I think this was a tricky one, right? Yeah, because there's a negative leading coefficient that messes people up, right? Okay, so in fact, I might even want to I want to bring up my I don't think I've done this yet, so yeah. This is 27 number 5, all right? Okay. Okay, so number 5, purple? Purple, okay, purple. Okay, so when is this real? Okay, to find the domain of f, we want the real values of x for which this output is real, okay? So f of x is real if and only if, you don't have to write that, but I like putting that in. If and only if the radicand is non-negative, 2 plus 5x minus 3x squared is greater than or equal to 0. Yeah. I can see how this inequality might have been difficult for people to solve because we have a negative leading coefficient. That really messes us up, right? So let's see. Let's do it this way. Okay, let's write this in ascending powers. Negative 3x squared plus 5x plus 2 greater than or equal to 0. All right. Now, I really don't like that negative leading coefficient. So why don't we do this? Why don't we multiply both sides by -1? So then we get 3x squared minus 5x minus 2. And what happens if we multiply both sides by -1 or any negative number? What happens? I should emphasize this in red. We're multiplying both sides by -1. This flips. That's really, really critical. That flips to is less than or equal to. All right. Any questions thus far? Right. Okay. So now, of course, there are various ways you can do this. Sign chart method, test window method. I still like my old parabola method. Okay. So let's use the parabola method. Okay. Consider graphing y equals this thing over here. All right. I know it's a parabola opening up, but I would like to know what the x-intercepts are. Let's find out where the zeros are. Okay, that's where this equals 0. I'm considering the parabola. Now, the fourth root messes things up. I'm just focusing on the parabola. We know how to graph those, right? You won't know how to graph that thing until maybe calculus. All right. So where's that equal to 0? All right, so where's this thing equal to 0? When you consider the x-intercepts, you can dispense with the inequality. That messes you up. Let's just Focus on this. And if you have to use a quadratic formula, that's fine, but old school factoring should work here. I don't think I was that cruel in this section. You did get a snake in 6, though. All right. All right. 3x squared, if it works, breaks up as 3x and x in either order. Ah, split signs. I hate those cases. Split signs. -2, because you get a heavier, like negative 6x, and a plus 1x over here. All right. Or use the QF. So then you get x equals -1/3. I'll cut to the chase. You said each of these equal to 0. You don't have to show that. I believe that you know the zero factor property, and I believe you can do this mentally. X equals -1/3, and x equals 2. So what does this parabola look like? Blue. Leading coefficient is positive, opens up. Here are your x-intercepts at -1/3, 0, and 2, 0. Parabola opens up. I don't care exactly where the vertex is, but here's a rough sketch. And I don't care about the y-intercept. All right. The value of 3x squared minus 5x minus 2 is the y-coordinate on this parabola for various values of x. I want to know the values of this, the values of y, that are less than or equal to 0. That surprises people. Less than or equal to 0. I don't want the wings. I want the smile. I want the smile. This is the piece of the parabola that's below the x-axis. It's a weak inequality with the bar. I do want the intercepts as well. All right. So it's not a union thing. Okay. The solution set to this inequality, the domain of f. The domain of f is going to be bracket, because I want those intercepts, -1/3, 2, bracket. For example, 0 is good. If you plug in 0 for x, you get this 4th root of 2, which is real. Yeah. So see, notice here, you often get wings, but sometimes you get the barbell in there too. 4 is all real numbers. That was like an odd root, right? Okay. Oh, you're welcome. Yes. Let's see. So 259. We did 259. 346G. Right. Okay. So wow, running out of colors here. Brown. Okay. And I don't think I've done that one yet. Right. Oh no, I think I have actually. Let me check this one. It's helpful if I've done this before. I think I have done G. Let me try to, maybe in office hours. What was it? It was 3, 3, 4. Huh, maybe not. That's okay. That's okay. We'll just do it from scratch. All right. All right. So, and then now this is, I do want this now. 346G. All right. Now, if that were a 0 there, that'd be awesome, but that's a 4. So the separating logs method is not recommended. Condense. The difference of logs is not the log of the difference. Not the log of the difference. It is what? It is not the log of the difference, but the log of the quotient. It's the quotient rule. Okay, so let's apply the quotient rule to the left side. The difference of logs is log of the quotient. So log base 5 of x over x plus 1 equals 4. We're applying the quotient rule. All right, questions? All right, let's do the zigzag. Oh, by the way, don't try to do anything here, right? Okay, there's not 1 plus x. Okay, so don't try to do any fancy stuff here. All right. Zigzag, exponential form. 5 to the 4th is that. This whole thing here. Okay. 5 to the 4th, you can use a calculator, equals x over x plus 1. Okay. I'm used to this number. 5 squared is 25, and 25 squared is 625. So I'm used to that number. Equals x over x plus 1. And again, people have trouble here because you have to think back to your algebra 1. And sometimes the algebra 1 pieces can be hardest. Multiply both sides by x plus 1. Bear in mind, x cannot be -1, but we'll catch that in the check anyway. Yeah, we'll catch that in the check anyway. All right. So on the left side, we have, in fact, I can type this in. So we have 625 times the quantity x, whoops, x plus 1 equals, just get x over there, right? These cancel out. All right. And then we distribute 625x plus 625 equals x, and then subtract x from both sides. Six 24x plus 625 equals 0. And then when you subtract the 625 divided by 624, you get x equals negative 625 or 624. And you have to show all this work. Well, maybe not like this over here, for example, right? But negative 625 or 624. Are we done? Are we done? Well, we're solving a log equation problem. We have to check. Problem is, you try to plug that into the original. See, this is a negative number, right? If you plug it right into here, you're dead. You're dead right there. Does not check. Does not check. If this thing has a solution, this is the only possible one, and it doesn't work out. The final solution set is the empty set. But of course, you cannot give me that answer only. You got to show me the work and show me the tentative solution and how you got there. Oh, yeah. I've done that too, by the way. Yeah, don't do that. Don't mix up sides. And this happens a lot with matrix problems. In chapter 8, we're going to deal with matrices, and a lot of people do things like writing wrong rows. I do that too. So sometimes, if you're having trouble, see if you mistranscribed the original problem. We all do it. But I'm sure many students were eager to see this also. Oh yeah, there's no excuse for not doing these because yeah, we've gone over these in class. I may well grade one of these where you show work. No, I haven't tried a tablet, but I think the mouse has worked fine. It's just pretty basic, but it works fine. Okay, I see 3, 4, number 2. That's the next one, right? 3, 4, number 2. All right. Red. Okay. So sorry if I'm triggering you. 3, 3, 4, number 2. All right. On the day of a child's birth. Yeah, I think I started this. That's okay. Let's do it. Let's do it. All right. 3, 4, 6, 3, 3, 3, 4. 2. You know, red is probably a bad base color. Actually, let's go with blue. All right. Okay. On the day of a child's birth, a deposit. So bottom line, this is compounded continuously. It's a PERT problem. It's a PERT problem. Okay. So again, this is 3, 4, 2. All right. PERT. So f of t, the amount you have in your account, or the child has in its account, equals p to the rt. All right. F of t equals pe to the rt. Positive. All right, so we want to know how old the child will be when there's 3,000 in the account. So we want to know when the value of the account, f of t, is $3,000. Okay, I won't put the dollars unit. 3,000 equals principal, the deposit is $1,700. E, that's a number, e to the 4.2% as a decimal. 4% is 0.04. 4.2% is going to be you put a 0 in front, 0.042. T. All right. So solve for T. Assume there are no further deposits or withdrawals. Give both an exact answer and an approximate answer. All right. Solve for T. All right. So let's start by, okay, I don't like this 1,700 in front. Let's divide by it. Let's divide by 1,700. All right. So we have the, okay, and then I'm going to divide top and bottom by 100. You don't have to, but they'll make it nicer. But I want to keep that exact fraction, though. Okay, don't do decimal approximations just yet. I want an exact answer. It's good to have that practice, and you'll keep more accuracy. All right, so we have 30 over 17 equals e to the 0.0 to t. All right. All right, question so far, question so far. Okay, now remember, we're trying to solve for t. So we'll bring that exponent down to earth. What brings that exponent down to earth? Well, we don't want the e there. Let's try natural log. So natural log of 30 over 17 equals natural log of this. I'll write it out. You don't have to, but ln of e to the 0.04 to t. All right. It's good to write down, though. All right. So on the left side, you have ln of 30 over 17. That's still exact. Ln of e to the blah is blah. That's by the inverse properties. All right. And then finally, how do we isolate t itself? We divide by the coefficient. And I show you various ways you can simplify this, but that would be exact. Okay, t equals that, right? In years, right? In years. And you can approximate that. Right. So t equals ln of 30/17 over 0.042, which is 42 over 1,000. You can multiply 1,000 on top and bottom, simplify. You can use the quotient rule to write it like that. Okay, so there are various ways of writing it. And I think it is instructive to see why this works, right? Why does this equal that, equals that, equals that? That's helpful, all right? And it turns out to be approximately 13.5 years old. So just around puberty time. Guess can get that money. Okay. All right, questions? Questions? Any questions? I think we've done the ones in chat thus far.
I have a question. How do you find that with your calculator? Like, how do you plug that in?
Oh, yeah. It's easy for students to make a mistake here. Again, it's a problem of grouping symbols. It helps if you have one of those newer WYSIWYG calculators. What you see is what you get. Where you type it in, you see the stuff on your display. But you put, so how would you calculate this? So something like, natural log, parenthesis, 30 divided by 17, and the parenthesis, okay, and the parenthesis divided by 0.042 equals. That should be okay. So I guess the key thing is making sure that you put the parentheses there.
Okay, yeah, I got it. Thanks.
Yeah. But no, I agree. That it's really easy for a student to make a mistake here, right? Oh, and one other thing. A lot of students do ln of 30 over ln of 17. That's different. That's change of base. So by any means, do not do that. Do not split the logs. The log of a quotient is not the quotient of logs. A lot of students make that mistake. All right. Anything else in chat? Okay, 332C. Yeah, I'm looking at the answer. Well, it's okay to peek sometimes. 332C. All right. Let's see. 332C. This one here. Yeah, yeah. Maybe blue again? Blue again? Dark blue? All right. That's a nice dark blue. 332C. Okay. All right. This one. Right. Okay. So see over here again. This is 332C. All right. So this thing here equals. Okay. Now again, I would accept answer only, but let's go through this step by step. Okay. Well, let's do this. We get ln of e to the sixth. Okay. So because of the product and quotient rules, it's going to be ln of this plus ln of this minus ln of that. You can do that in one fell swoop, and that's from a combination of the product and quotient rules. ln of e to the sixth plus ln of the cube root of x minus ln of y to the seventh. All right. Now, the cube root of x, remember, is x to the what? The cube root of x is x to the 1/3. All right. And these exponents smack down. So I can tell right now that, okay, the 1/3 smacks down here. 1/3 ln of x minus 7 smacks down here. We assume x and y are positive. No absolute value, that stuff. It's odd anyway, right? For odd, you don't put absolute value anyway. Over here, what's ln of e to the sixth? What's ln of e to the sixth? By the inverse properties, we get 6. So 6 plus 1/3 ln of x minus 7 ln of y. Right. And you don't really need grouping symbols or parentheses, but still, I think it's nice to indicate the argument. Okay. Any questions? Any questions? I'm gonna write down the name of that tablet. Look into that. Yeah, I have thought about getting a tablet with a stylus. Yeah, maybe. Why not? I could probably afford it. It's just a matter of seeing if it works well with all this. Yeah, I might want to try it. Why not? All right. Oh, okay. Thank you. Yeah. I guess I didn't know where to start. Yeah, I needed someone to recommend one to me. All right. Yeah, I could afford that. Yeah. And in my line of work, it'd be worth it. Okay. Okay, thank you. Yeah, it was a matter of where to start, right? It's like if I Google tablet, it's like, oh gosh. No, thank you for a recommendation. I just didn't know what to go with. but thank you very much. Yes. I've thought about it. Yeah, I've thought about it. Yeah, I just didn't know where to start. Thanks. Okay. But I hope that this is at least yeah, basically satisfactory. I might move up though. 333C. Okay, the battleship 333C. All right, this is 332C. I would like to use different pages. Okay. Okay, so the answer. Okay, here are the questions. Okay, 333. Oh yeah, 333C. Yeah, we're gonna go to this. We're gonna do this anyway. Let's go purple. 333C. All right. Okay, so let's condense this thing. Okay, and in fact, what I can do is again, like for A, I can show you the rhythms of the shortcut and then show you why it makes sense. So if the shortcut seems too much of a hack to you, then I'll do it the long way later. All right. So here's the shortcut for 333C. All right. So this thing here, one fell swoop. What's going on here? Equals, all right, ln of, that's going to be something I probably want in parentheses, right? The 3 comes up by the power rule, the basketball rule, the 3 comes up. So you have ln of x cubed. X cubed is a factor of the numerator. Plus sign, the 4 comes up. Y to the 4th. That's also a factor of the numerator in the argument. Over, okay, because there's a minus sign in front. Comes up as 3/4, z to the 3/4. You don't have to put this in radical form, but you could, z to the 3/4. Also, another minus, we have another factor on the bottom, w to the 5th. Okay, so that's the rhythm of the shortcut. And you know what? I don't mind people using the shortcut because your calculus teacher will likely expect you to have this facility with logs, right? That's what you pick up in pre-calc, a facility with manipulating the logs like that. By the way, did I get my own right answer? Okay, ln of x to the 3rd, y to the 4th over, and then you can either put the power form or the radical form. Make sure you don't extend the radical too far, okay? But still, some students might be going, well, you know what? I'd rather see it step by step. And hey, you're being conscientious mathematicians, all right? So let's do it step by step also in green. Okay, it's a worthwhile effort. Okay, so first off, equals. So first of all, let's use the power rule. Okay, so all the coefficients I'm going to bring up. So the given problem, given expression equals ln of x to the 3rd plus ln of y to the 4th. Okay, minus ln of z to the 3/4 minus 5 ln of w. Actually, if you do it step by step, then the algebra is a little bit trickier, actually. Okay, but it's worth looking at. Oh, I may as well bring this guy up, right? I can do this. No, yeah. Moves over. All right. Okay, so the sum of the logs equals the log of the product. That's a product rule. Ln of x cubed, y to the 4th. How about this? Minus, let's factor out a -1. See, that's why the algebra, it's kind of trickier to see it this way. Factor out a -1 from both terms. ln of z to the 3/4. That's a plus sign, a plus sign. You're factoring a -1. ln of w to the 5th. Okay. Well, I'm glad you went to the tablet to me. I might actually do some Amazon shopping this weekend. Good timing. I've been too busy for that. Yeah, time for an Amazon shopping spree. Okay. ln of, so great timing. ln of x cubed, y to the 4th. Sometimes you got to treat yourself to an Amazon shopping spree. Okay. Minus, all right, take a look at this, same thing. Sum of logs is log of the product. All right. But see, this factoring out of the -1, that helps you see that. The sum of logs is log of the product. And then you won't mess up your signs or anything, right? Sum of logs is log of the product. And then difference of logs is log of the quotient. I refuse to rewrite this. It's that. I refuse to rewrite it. You understand why. Okay. Difference of logs is log of the quotient. It's right there. Yeah. I'm not going to rewrite it. Yeah. Come to think of it, maybe I will get that tablet. Then I'd actually think about doing that. Oh, thank you. Yeah, yeah. That's the thing. I didn't know. Yeah. All right. Any questions? Any questions? All right. Any questions? Any questions? Oh, 314. Right. All right. 314. Here, yeah, I think I have some good notes here. I was working with a student one time. I think it's worth me trying to retrieve my notes on this. I think it was during an office hour. If I can locate it. With a little bit of luck, I had some good notes here. No, it's gonna take too long. Yeah. All right. Okay. So okay, so I'll do it again. Let's see. On the day of this was 4, right? Right, 314. Okay. Green. All right. Olive green. All right. Deposit compounded annually. So it's not PERT. It's the uglier formula. All right. So, but you know what? I'm going to do it right here. Okay. So I'll give you an idea of what to do. Right. So the standard compound interest formula looks like f of t equals p, and it's kind of ugly, right? It's the quantity 1 plus r over n all to the nt. All right. And on before I gave exams, I would give this to students, right? Okay, so we want to know how much you're going to make. after 8 years. So you're going to calculate f of 8, the amount in your account after 8 years, equals the principal was that deposit of $1,700, $1,700, times the quantity, okay, 1 plus, now here's the thing, for annual compounding, n is 1. N is 1. You get 1 compounding per year. N equals 1. It's like that magical day of the year, right? And R is, again, my favorite percent, right? 0.042. Because we were comparing, right? With the 4.2%, I got... yeah, because we revisited it. Oh, yeah. So the idea is that I was going to have you use the model. Right, okay. Because that 4.2% was familiar. It came up later. Okay, so anyway, R is 0.042, N is 1, right? So you get 1 plus 0.042, because N is 1 anyway, right? Again, N is 1, T is 8, right? N is 1, T is 8. So the 8th, okay, 1 times 8 is 8. So work this out. And remember, your final answer is in dollars. All right. Okay, now in part 5, here's how it differs. 5A. What, red? I'll do it in red. Okay, over here, f of 8. Okay, equals, again, the deposit is $1,700. We usually save the unit dollars till the end. Okay, times the quantity, 1 plus, okay, R is 0.042. All over, for monthly compounding, N is, how many compoundings per year? 12. Okay, like the 10th of the month or whatever, right? All to the NT. N is 12, and T is 8. I'm running to this guy here. But be careful. You might want to process that immediately on your calculator. I know 12 times 8 is 96, and you might want to observe that early. Because remember, the most common mistake students make is that they forget to group the exponent. You have to either group the exponent as 12 times 8 or find out what it is directly. But anyway, that's the formula. And again, your answer is in American dollars. Continuous compounding is PERT. PE to the RT. Oh, I better use a different color. Blue, purple, right? Continuous compounding, PE to the RT. So f of 8. You know, up here, maybe I should use G, right? Because I used F over here. Maybe I should just use G here. Use G for this, all right? And then in purple, H for this. Okay, H of T equals PE to the RT. All right. So P again is $1,700. E to the, okay, R is what? 0.042. T is what? 8. Oh, okay. Well, it's going to be T, right, in general. And then for H of 8, you plug 8 into here and also plug 8 into here, and you work that out. Okay, answer in American dollars. Okay, any questions? Any questions? So we're still in class time. It's 9:13. We're still in class time. Although, thank you for your commitment. Right? It's been a couple hours. Right? Thank you for your commitment. I'll keep going. Any questions? So, you're welcome and thank you. Thank you certainly. Yes. All right. Okay. And remember, the homework is due tomorrow at midnight. So let's do this. Let's take a 3-minute pause. Let's come back at 9:17. All right, in 3 minutes, and then gather your thoughts. And then if you have some more questions or issues, let's take a 3-minute pause. All right, as you gather your thoughts. Okay, I won't even bother pausing the recording. All right, so coming back. Let's see. All right, 274. Yeah. Oh, yeah. Okay, here's the key. Here's the key. Fifth root. I better put this in red. Number 4, here's a key. Fifth root of a polynomial. Anytime you have the odd root of a polynomial, domain is all reals. We could have the 11th root of a 100th degree polynomial, domain is all reals. It's kind of a trick question. So then you'd write the interval form for all reals, which is this. What kind of a trick question there? All right. Anything else? Okay, looking over your homework. Any questions, concepts? Let's do it again. So 9:22. Okay, 3 more minutes. If you have any other questions, put in chat or talk. So 3 more minutes. All right. Any questions? Yeah. Yeah, so am I. That's why I'm doing the 3-minute thing. I don't want to just stare at my screen. Any questions? Otherwise, do you want to do another 3 minutes? Again, you're in charge. You're in charge. So 927. 927, come back. So I'll do this until our class time ends at, well, okay, 9:27, the next one's at 9:30, all right? And if no one has anything, then we'll end at 9:30. But then I'll go beyond 9:30 if you want me to. All right. All right. Back in business. I was wondering, I was wondering how you want to show work for. Oh, yeah, chapter 4. Let's take a look at chapter 4. Why not? I guess it's a good time after we've done the chapter 3 stuff, right? Okay. Or to chapter 2 and 3. All right. Let me grab the 4. Time to grab the 4 homework. All right. Okay. So wait. 4. Actually, it's homework 3. It's homework 3. Okay, so homework answers 3, homework questions 3. There we go. Oh no, you don't have to show work. And if you want to, you're welcome to, grab this, screenshot it or whatever. No, you don't have to show any work. Well, I'll put it this way. Do work insofar as it helps you, okay? Do work insofar as it helps you realize why the values are what they are. I'll accept answer only, but, do whatever it takes to help you figure out the table for yourself. But you don't have to show work. You're welcome. Okay, so as we approach 9:30. Okay. So why don't we do this? I'll give you another minute to gather your thoughts, but if you think that you might need me in a few minutes, say so or chat at me. But otherwise, we'll close shop at 9:31 unless someone says something or chats at me, and I'm happy to stay longer. But I just don't want to stare at the screen for 10 minutes. All right. Okay. So 1 minute. Let me know if you think you might need me in the next few minutes, or you can always email me. Thank you for your commitment. Yes. All right. So I do have a request here: 4.2 to 4.4, number 5. Ah, yes, yes. Okay. Now it's based on the idea of similar triangles. Students have asked me about this before. So the idea is that it's a 30, 60, 90, and the classic one looks like this. All right. I mean, I have the same angles as here, right? It's a similar triangle. Now, the classic one goes, if it's 1 meter, let's say, for the shortest side, okay, on a 30, 60, 90, then it's √3 meters for the medium side, which faces the medium angle, the 60-degree angle, and it's 2 meters for the hypotenuse, which is twice as long as the shortest side. Remember, smaller angles, the 30-degree angle faces the shortest side, and the medium side, 4 meters, faces the medium angle, the 60-degree angle. The hypotenuse, the longest side, faces the right angle. So here's the thing. It's similar triangles. How do we get A? It's the same ratio as here to here. From the medium side to the shortest side, the ratio is √3 to 1. Okay? So basically, the medium side is always √3 as long as the shortest side. 4 is going to be √3 times as long as A. Solve for A. Divide both sides by √3. So you get 4 over the square root of 3. And then you rationalize. A equals 4 √3 over 3. That's what you get when you rationalize. You don't have to show me the rationalization process. Okay, I accept you know how to go from here to here. And the units in meters. That's from the √3 to 1 ratio. It's similar triangles. This is to this as this is to this, right? Again, the hypotenuse is twice as long as the shortest side. Just like over here, the hypotenuse is twice as long as the shortest side. So C is going to be not 4 √3 over 3, but 8 √3 over 3 meters. And those are the answers, right? C equals 2A, correct. C equals 2A. And if this is B, then B is √3 times A. I'm assuming that A is the shortest side though, okay? A is the shortest side. A is the side facing the 30-degree angle. But it's based on these proportions, right? We have the same proportions here. Right. You're welcome. All right. So we'll take these minute pauses. Good night. Okay. So at 9:34:30, 9:34:30, 9:35. At 9:35, let's take inventory. Any questions? Or if you want me to wait up in 5 minutes, if you think you'll have something in 5 minutes or so. Oh, thank you. Thank you for your hard work. Yes, good night. Yes. Okay, another 30 seconds unless you have a question. I'll close shop in 30 seconds. I'm happy to stay, but chat at me, or if you think you might need me in 5 minutes, I'm cool with that. You're all good? 10 seconds? Questions? All right. Have a good weekend. Thank you for your hard work. The homework is due Friday midnight. Have a great weekend. I look forward to seeing you next week. All right. Take care, everyone.